Hi! In this lesson, we're going to dive deeper into artificial intelligence, learning more about the popular applications and developments in the field, including machine learning. At the highest level, we like to talk about a few types of AI, most notably narrow AI and general AI. Any examples of AI that you've seen in your life will fall into narrow AI. It's the AI that is built for a specific purpose. Things like the recommendation systems in Spotify, YouTube, and Netflix, language recognition and generation like ChatGPT, Siri, and Alexa, and what's used in self-driving cars. In contrast, general AI is a more human-like intelligence. It's versatile across various cognitive functions and tasks, having broader capabilities. General AI is what you might see in TV and movies, like The Avengers, Star Wars, Westworld, and Her, to name a few. While narrow AI is commercially available in different products, general AI does not yet exist, and is a long-term goal of AI research. Under the umbrella of AI, there are a variety of exciting developments and applications currently underway. Machine learning, and its subset of deep learning, is one of the most popular and widely applied fields of AI, which is why we'll be focusing on it in this video. There are also some really exciting applications of AI in the works as well, like natural language processing, generative AI, computer vision, and robotics. There are many techniques and approaches that these will share, and many use machine learning in some capacity. So let's talk about machine learning in more detail. Machine learning is a branch of AI that uses data and algorithms to learn about a situation in order to make future predictions or decisions. Imagine here we have a blank slate in a computing system. We have provided it information, and through a variety of techniques and algorithms, this computer learns from it and develops an AI brain. Once this AI brain is established, it can then do things. It can output informed predictions, ideas, recommendations, insights, and groupings. When we choose to use a machine learning setup, we are choosing a particular machine learning model to use. A model is just a variety of mathematical, statistical, and algorithmic expressions packaged together. It's what we called our AI brain, and it's what is going to learn from our input data. Each machine learning model has its strengths and weaknesses, and we will choose one based on the context and our needs. A linear regression model, for example, is simply a line of best fit that you've seen in your math classes. Using that line of best fit, the model can make predictions about future inputs. In this class, and in many instances, you don't actually need to know the mathematical details behind the workings of the model. Just remember they are built on mathematical and algorithmic logic. In order for the model to learn from the input data, it goes through a process called training. In many machine learning applications, we are providing a training dataset for a computer to learn from. The training dataset can include any variety of information, from numerical, text, images, songs, etc., though at some point in the process, all of the data will be represented numerically, since that's how computers process information. When we train our models, what we're really doing behind the scenes is fine-tuning the parameters of these mathematical components. Remember, the model starts with no conception of what is going on. It knows nothing. But as it goes through the training process, with more and more data, it starts to learn about the situation that is presented in the training data. As the training completes, the model has learned from the input data and has a conception of what story the data is presenting. It will never be perfect, for a variety of reasons, but it will be good enough for us to use. Before we put the final stamp of approval on the trained model, we'll often use some additional, different input data to test how well the model is trained. Depending on the results, we may go back and tweak parameters related to the model or the training dataset. When the training and testing period are done, the model is now ready to be put to use. Let's look at an example where we want to develop a machine learning model that will be able to tell the difference between cats and dogs. There are a few different approaches we can take with this, but for this case, we'll use data that contains images of cats and dogs that are labeled as such. And thus begins the training process. When training is complete, it has learned the differences between cat and dog images. Then we test it with a few new images to see how well it does. The first data point is identified correctly. The second as well. For the third data point, the model incorrectly thought this animal was a dog instead of a cat. And that's okay, since we know it won't be perfect, and to be honest, that cat kinda looks like a dog anyway. And the final data point was identified correctly. At this point, we can go back and tweak and refine our model and training process, or we can decide that the model is good enough for our needs and move forward. It's good enough for us, so we upload it to our robot and release it to the world. Good, robot. Before we finish here, there are a couple things worth mentioning. Our model only learns from the data we use to teach it, so the quality and quantity of the data is really important. For example, what if there were more or less training data points? How do you think that would impact the success of the model in the real world? Well, in general, the more training we can offer, the better understanding it will have, with the potential downside being that too much data can make the model harder to train and work with. Or, for example, what if we specifically removed all of the solid colored dogs and cats? Then the model has not learned much about solid coloring as a feature in recognizing the animals. This could prove problematic when it has to recognize one in the real world, and its training was absent of these types of animals. This is an example of bias in the training data, and it's something that we have to be very careful about when curating the data set we use to train our models. Ideally, we want our data sets to be representative of the population we're using it with. Great! Let's learn more about the types of machine learning models.